Hello guys, how are you all? Welcome back to the lesson today. And today we are going to do a very important question of Heron's formula, and that is exercise 12.2 question number 9 to find the area of a trapezium. Trapezium, which is again one of the type of quadrilateral. This is a very important question from examination point of view. So guys, please understand the concept and go through the method very carefully. So let us see what is being asked in the question today. A field is in the shape of a trapezium whose parallel sides are 25 meter and 10 meter. So very first, a trapezium is given to us. Trapezium is a shape whose two sides are parallel, two opposite sides are parallel, and the another pair of opposite sides are non-parallel. So very first, let me draw a trapezium here. So suppose this is the shape of a trapezium, and I'm giving it name A, B, C, D. So this is our trapezium ABCD, in which the parallel sides are. So what are the two parallel sides? The parallel side is AB and CD. The two parallel side is 25 meter and 10 meter. So the longest side, I'll write it as 25 meter, and the smaller side, the shorter side is 10 meter. Now the next line, the non-parallel sides are of 14 meter and 13 meter. So here the non-parallel side, one of the non-parallel side, I'll consider it as 13 meter and another side as 14 meter. You can write 14 here and 13 there. There will be no difference in the solution by shuffling. But yes, in the parallel sides, when the dimension of parallel sides, you have to be careful. The shorter side will get smaller distance and the longer side will get bigger measurement. Now, so this is done. The trapezium is ready, A, B, C, D, with all the dimensions. Parallel side as 25 and 10, non-parallel sides as 14 and 13. Now we have to find the area of this figure. If the height of the trapezium was given to us, we could have find the area directly by using the formula of area of trapezium, half the sum of parallel side multiplied by height. But here, since the height is not given to us, so we have to use something related to our chapter, Heron's formula. So let us see how to do that. So the trick for this, the basic concept and the basic method which you have to use here is, we will divide this trapezium into two shapes, and that is one shape as a parallelogram and another will be a triangle. So how we will do that? We will make a construction here, and construction will be from point C, I will draw a line which is parallel to AD. So parallel to AD, I have to draw a line from point C, and let me give it name as E. So CE is a line which is actually parallel to AD. So now here, as you can see in the figure AECD, AE is parallel to CD and AD is parallel to CE. That means what this figure becomes? This figure becomes a parallelogram. This is a parallelogram. So in the solution, we will very first start with the construction part, and our construction is draw CE parallel to DA. So this is our construction part, that we have drawn line CE which is actually parallel to DA, and therefore now instead of therefore, now since now wait now as AD is parallel to CE and DC is parallel to AE. That means, what does it implies? It implies that AECD is a parallelogram. That means our figure AECD becomes a parallelogram. Now with this, let us find out the dimensions also. Now here you can see that our complete distance AB, this complete side AB is actually 25 meter. Now as I have drawn this parallel line, this line CE, so what will be the dimension for AE? Since AE is parallel to CD, that means our AE will be of 10 meter. And then what will be the dimension of EB? Yes, EB will become 15 meter. Similarly, on this parallel side, since AD is 13 meter, that means CE is also 13 meter. So, now in triangle CEB, very first we will start with CEB. Why we will start with CEB? Because we have to find the height of this trapezium to find the area. So to find the height of the trapezium, very first we will find the area of this triangle CEB, whose all the three sides are given. So in triangle CEB, one of the side is 13 meter, another side is 15 meter, and third side is 14 meter. So all the three dimensions are given to us. Let us start finding the area of the triangle by using Heron's formula. So semi-perimeter will be 13 plus 15 plus 14 divided by 2 gives you 42 upon 2. That means the value is 21. Now with this 21, let us find the area of triangle CEB. So area of triangle CB is square root S minus A, S minus B, and S minus C. Put the value 21, 21 minus 13, 21 minus 15, and 21 minus 14. Solving it up, 21 into 21 minus 13 gives you 8. 21 minus 15 equals to 6. 21 minus 14 is equals to 7. Making the factor here 21, 3 multiplied by 7. For 8 we can write 2 into 2 into 2. For 6 it is 2 multiplied by 3. And lastly as 7. Let's make the pair now. So there is a pair of 7. 7 comes out. There are two pairs of 2. So that means 2 multiplied by 2. And there is one pair of 3. So there is 3 out of the square root. Multiplying here. So 3 7s are 21 multiplied by 4. That means the area of this triangle CEB. The area of triangle CEB is 84 meters square. So we are done by finding the area of triangle CEB. Now with the help of this area, can we find the height CF? If I name it as CF, can we find the height here? So answer is yes. Now also area of triangle CEB is also equals to half into base that is EB, and height which is CF. Area of triangle CEB according to our first result, it is 84 meters square. So it is 84 meters square equals to half into BE 15 into CF. Get the value of CF from here. So that is 84 multiplied by 2 divided by 15. Simplify here. Dividing it by 3, 3 5s are and 3 2s are 6 and 8. So CF is equals to 28 into 2, 56 upon 5. meter. We will not convert it into decimals, just leave it in the fraction format 56 upon 5. And moving further, because still we have to find the area of the field, that means we have to find the area of this complete trapezium. So now at the last put the formula area of trapezium. So now area of trapezium ABCD is equals to, now put the formula of area of trapezium. So that is half the sum of parallel sides. What are the parallel sides? The parallel side is AB plus CD. Multiply by height. Put the value half in the bracket. AB is 25 and CD is 10. So it is 25 plus 10. And what is the value of height? According to our above result, the height is 56 upon 5. Simplifying here, 1 upon 2 multiply by 25 plus 10 gives you 35. Multiply by 56 upon 5. 5 7s are 35 and dividing it up here with 2, we will get 28. So now your result is 7 into 28. Multiply the value here 7 8s are 56 and 7 2s are 14, 196 meter square. So this is how we can find the area of any trapezium, a normal trapezium or an isosceles trapezium in which the non-parallel sides are also equal. So this is how you can find the area of trapezium. First of all, making the parallelogram constructions, and we will make the parallelogram, then finding the area of the triangle, find up the height, and at the last put the formula for area of trapezium. I am sure that you all have understood the concept carefully and properly. Thank you for the lesson, guys.